Okay, so right now we're going to talk about how we can relate kinematics with Newton's second law of motion. So we're going to solve through this example problem and show how we can relate those two. A 4,600 kilogram helicopter accelerates upward from rest to a velocity of 20 meters per second in 10 seconds. Determine the lift force exerted on the propellers by the air. Now, first thing that we need to do is to see what the problem is trying to tell us to figure out. Now, what the problem is really telling us is to determine the lift force. So, we know how to quantify forces. It's as simple as drawing a force diagram and then using our sum of the forces equation. So, I'm going to first, before I even draw the force diagram, just start off with a diagram. Just allow me to visualize the problem. So, this is going to be a very crude sketch of a helicopter. But still, it's going to be good enough for the purposes. This is a helicopter. Presumably it's up in the air, seeing as it's accelerated upward from rest to that velocity of 20 meters per second in 10 seconds. So this is going to be my helicopter. It's up in the air. This is going to be the ground down here. So it went from this starting position of 0 meters up to some final position, which the problem is not telling us. We know it goes from rest, so a starting velocity of 0 meters per second, and it ended up with a final velocity of 20 meters per second, and that all occurred over a change in time of 10 seconds. The problem's not telling us what the acceleration is either, but we know that this is what's going to be occurring, and we know that the mass of the helicopter is 4,600 kilograms. But we're trying to determine the lift force. So I've already identified the variables, but that's kind of getting ahead of ourselves. We need to figure out what forces are acting on this thing. First thing first is going to be a force of gravity acting on the helicopter, because that's going to be the first force we draw every single time ever. A force of gravity on the helicopter by the Earth. That's pulling this thing down. Then after that, we just need to see what's touching the helicopter to see what could be exerting a force. It's up in the air right now, so the air could be exerting a force, and in fact, we know it has to be exerting a force because we're solving for the lift force. So we're going to have a force of lift acting on the helicopter by the air. Now, because this thing went from the ground up to the air, from rest to some non-zero velocity, means it accelerated upwards. So that means we need to have more upward force than we do downwards force. So that's a force of lift on the helicopter by the air. And then when we have it set up that way, our sum of the forces equation, seeing as that's the only two forces that I know are existing here, it's the force of lift minus the force of gravity. Now, other things that we can do with this, we can start to assign quantities to the forces that we know. Determining the quantity of a force of gravity is really straightforward. On Earth, it's 9.8 newtons of force for every kilogram of mass times the mass that we have. In this case, it's 4,600 kilograms. So the force of gravity acting on this helicopter is going to be 45,080 newtons. Now, if the forces were balanced, we could be done. Say, hey, the forces are balanced, so the lift force would have the same amount of force as the force of gravity. However, because it's accelerating upwards, we can't necessarily do that. Instead, what we're going to need to do is to rearrange that sum of the forces equation that we ended up writing, that applies to our force diagram, and rearrange it. So, the way that can be rearranged is our force of lift is equal to our sum of our forces plus the force of gravity. Now, we just calculated the force of gravity. It is 45,080 newtons. And we know that from Newton's second law, the sum of the forces is equal to mass times the acceleration. And if we just add those together, we can figure out our force of lift. But this is where the problem starts to come in. We don't know the acceleration. That's something that we need to use our kinematics to solve for. Acceleration is included in the second law equation. Sum of the force is equal to mass times acceleration, and it's included in our kinematic equations. That is the length between these two topics that we've been learning, kinematics and forces. They are linked with the acceleration. So that's where we need to take our kinematics that we know, what variables, and determine an appropriate equation. One equation that we can use is our final velocity is equal to our acceleration times time plus a starting velocity. If we're solving for our acceleration, we can rearrange this equation. So that way our acceleration is equal to the velocity minus the initial velocity all over our change in time. So that way our acceleration would be 20 meters per second minus the initial 0 meters per second. All of that occurs over a time of 10 seconds. So that way the acceleration of this helicopter is 2.0 meters per second each second. And we know that's, well, this should be a positive value, which indicates that the acceleration is upwards. Now that we have that, we can take that acceleration and plug it into the same equation. And then just to kind of save us some space, I'm actually going to end up drawing that up here. So our lift force is equal to the mass, the 4,600 kilograms of the helicopter, times the 2.0 meters per square second of the acceleration, plus the force of gravity, that 45,080 newtons. Now, in order to figure out the sum of the forces, it's the 40,600 kilograms times 2.0 meters per square second. So the sum of the forces is 9,200 kilograms times meters per second squared, or newtons, plus still the force of gravity, that's 45,080 newtons. So overall, our lift force is just the combination of the downward force of gravity plus however much some of the forces we have to show how much bigger the upward force is than the downward force, which when I add those together would be 54,280 newtons. This is going to be the lift force acting on the helicopter, 54,280 newtons. Just to quickly summarize what we did there, as always, I recommend drawing a diagram first. That's what I recommended when we were doing kinematics. That's what I recommend when we're doing force diagrams. And when we put these two together, it just makes sense to start off with a diagram. Identify the variables you know, and then that can kind of frame your thoughts. Start off with a qualitative force diagram, and then quantify it the way that we know how, including the sum of the forces equation. And then ultimately use your kinematics in order to determine the acceleration. And then once you have all of that, it's just math to end up solving for any missing variables that you have.